Let's talk about something quants absolutely love, which is convexity. So imagine you're standing at the top of a giant bowl shaped valley. No matter where you drop a ball, it will always roll to the same bottom point. And that's the beauty of convexity. So there's only one global minimum or one global solution. There are no traps or no dead ends. Now let's contrast that with a jagged mountain landscape. Drop a ball there, and it might get stuck in a small ditch, and you think you've reached the lowest point, but actually, the true valley is somewhere else. And that's the problem with non convexity. You can get fooled by local optima. Think about baking cookies. You want the perfect oven temperature. In a convex world, the graph of cookie quality versus temperature has one smooth peak. Too hot or too cold, quality only goes down. There's only one best choice. In a non convex world, the graph is actually bumpy. You might find one decent looking peak at about 180 degrees C and think that is it, but actually 190 degrees C produces even better cookies. Convexity guarantees that when you optimize, the answer you find is the true best answer, not just a decent one. So in quant finance, convexity is what makes our optimization problems solvable in practice. Take risk model calibration. When quants estimate parameters to minimize prediction error, say in value at risk backtest, they often rely on convex loss functions like squared error. Why? Because convexity ensures the optimizer will always find the true best fit for the data. Another example is least squares regression, a workhorse tool across quant research. The objective function there is convex, which guarantees that whether you run it on a laptop or a supercomputer, you'll always land on the same unique solution. And without convexity, two quants could run the same code and end up with completely different answers depending on where their optimizer started. So, when quants say they love convex problems, it's not just math jargon. Convexity gives us certainty. It means algorithms won't get lost, models won't be unstable, and decisions won't be built on shaky ground. So, from cookies to commutes, from error minimization to risk calibration, convexity is the quiet backbone that makes optimization reliable. If you have not checked out the video on optimization problems in quant finance, check it out in the link below. Until next time.